Okay, so as DT mentioned, this is smooth sailing to the Azure cloud, a guided flight path of PaaS offerings. My name is Yuki Hata. I work for DCAC, and let's go ahead and get started. Okay, so I have my email attached here, yuki@dcac.com. Feel free to please go ahead and email me there if you have any questions or if you want to just go ahead and reach out. I am on LinkedIn and I'm also on Twitter, or also known as X, at Hata SQL. A couple things about me. I'm a first-gen American to two Japanese parents. I was born and raised in California, and I grew up playing soccer. I also just ran an Olympic triathlon. I do jujitsu. So I love all things outdoors. Also a breakfast burrito connoisseur, which is um, all of your favorite things in a breakfast wrapped in a warm tortilla. It's my favorite thing. Okay, so enough about me. Let's go over what we'll be talking about today. So the agenda. First and foremost, I want to go ahead and do a quick little review of what the PaaS offerings are and what that kind of entails. We'll talk about why someone would want to move to the Azure cloud. And with those PaaS offerings, we'll be talking about two distinct options. One is what is Azure SQL Database. The other is Azure SQL Managed Instance. With those two, we'll talk about some differences and some similarities, and we'll talk about which one is best suited for you after we go over all those options. Okay, so first and foremost, what is a PaaS offering? Well, the one that we're going to really focus on is called a platform as a service. So if we look at this graph on that far left, that is on premises. So in green, that's everything that you're going to be managing. So on-prem, you'll be managing everything with data, access, all the way to storage and networking. As you slowly move towards that right, towards that cloud provider, so with infrastructure as a service, your management decreases. In platform as a service, which we'll be talking about, you're only going to be managing that data and access and that application. So if you're lazy like me, that sounds like a dream come true. Okay, so with this platform as a service, let's see what Azure offers. So as I mentioned today, we'll be talking about Azure SQL Managed Instance and Azure SQL Database. So as we slowly move from on-prem to software as a service, you'll see that our administration overhead is going to decrease as we go along. Okay, so let's see why we would want to move to Azure. So one of the biggest things when transitioning to Azure, I think one of the biggest perks is how easy it is to scale. So I know my mentor John, he was saying back in the golden age or the olden days, just to scale something out, it would take weeks. So you have to order some parts, you had to take some time to get there, and by the time you install everything, it's already out of date. Luckily with Azure, you could scale with a click of a button, a scale, super quick, and with that, it's also cost saving. You're not going to have to be managing things physically. It's all virtual, which is great. It's also going to provide some high availability and advanced security features that we'll be discussing later down the road. Okay, so Azure SQL Database versus Azure SQL Managed Instance. Well, in a brief summary, Azure SQL Managed Instance is going to be easier for that lift and shift option from on-prem to Azure Cloud. It's going to be best for modernizing existing apps. Whereas Azure SQL Database is going to be really great for those that want to scale, and it's best for modern cloud applications. Okay, so the first one that we're going to go ahead and dive into is Azure SQL Database. So what is Azure SQL Database? Well, as I mentioned, it is best for those modern cloud applications. And you'll see some really cool tools that we can discuss with Azure SQL Database that's going to be great for scaling. Okay, so some key features with Azure SQL Database is you could deploy it with a single database or an elastic pool. We have a thing called hyperscale and serverless compute, which are both great things that we'll be discussing. It's going to provide high availability, and it's actually going to have the industry highest SLA, or service level agreement, of 4 nines and a 5, which is a promise of only 4 minutes and 3 seconds of downtime, or 2 minutes a month of downtime, which is amazing. One second here. Okay, so when we're going to transition to the cloud, let's go and talk about what those deployment options look like when we use Azure SQL Database. So we have two options. We have a single SQL database or an elastic pool. Now that single database, we're going to be able to use things like hyperscale and serverless compute, which is going to allow for 100 terabytes of data. And with elastic pools, that's going to be really more for resource sharing, and it's going to be a little bit more for those that want some price optimization. Okay, so with deployment, let's talk about purchasing a Azure SQL database. So we have two options here. We have the first one, which is a database transaction unit, also known as a DTU-based purchasing model. And we have the virtual core, also known as the vCore-based purchasing model. So let's go and take a deeper dive into both of these options and see what that kind of looks like. So if we take a look at this graph, we have that DTU model on the left and that vCore model on the right. So with that DTU model, it's going to be really a bundled measure of CPU, memory, and I/O all wrapped up into one. It's a pre-packaged unit. It's going to be designed for those that have a predictable performance. But if we look at this graph, it is somewhat inflexible. So if we do increase that compute, that storage is also going to be increasing. So they're both directly correlated. And so vice versa, if you increase storage, that also means that compute is also going to increase. On the other hand, on that vCore model right here on the right, we have compute and storage. They're going to be pretty much isolated. So they're going to be, you can independently choose compute and storage resources. So if you increase the compute, that doesn't necessarily mean that the storage is also going to have to increase, and vice versa. Same thing, if you increase that storage, that also means that compute doesn't have to increase. Now that vCore model, because you have more granular control, it is going to be that recommended option. Okay, so with the purchasing cores, let's service tiers, or let's go now look into service tiers after the purchasing model. Okay, so with service tiers, within the DTU-based purchasing model, we have three options. We have the basic, the standard, and the premium. So one thing you'll notice is the uptime SLA across the board is going to be great. You have that 4 nines. Once you go into premium, that's where we see the 4 nines and a 5. So that's even better. The CPU, it's going to increase as you go from basic all the way to premium. The storage is also going to be increasing from 2 gigabytes all the way to 4 terabytes. And the maximum backup retention, it's going to be set to 7 days with basic. And with standard and premium, you can adjust it all the way to 35 days. Now, if you need more than 35 days, you can do that using long-term backup retention, but we'll soon discuss that later on. Okay, so this is DTU. Let's go and take a look at what vCore looks like. So with the vCore-based purchasing model, we also have three options. We have the general purpose, business critical, and the hyperscale. So with general purpose, it's going to be best for those generic workloads and most business workloads. Business critical is really going to be meant for those that have the high I/O. Hyperscale, it's going to be very wide. So the IOPS, as you can imagine, it's going to be increasing. And with storage size, this is where you want to kind of think about when you're going to be transitioning is your storage size. So with general purpose and business critical, that's going to be around the same. It's not going to be too much of a difference. The biggest change you'll see is the I/O workload. So with storage size, you'll see 1 gigabyte to 4 terabytes. But with hyperscale, that's where you're going to see a huge difference. So with hyperscale enabled, you could go from 10 gigabytes all the way up to 100 terabytes, which is huge. And we'll see some differences with the storage options. So with general purpose, we're going to be using what is called a remote storage. And then with business critical, we'll be using local storage, which is going to be a little bit faster. And with hyperscale, it's going to be a mix of local and remote storage. So within these storage options, let's see what that kind of looks like. So with remote storage, if you're using basic, standard service tier in the DTU-based purchasing model, or if you're using general purpose, this is what the background is going to be kind of looking like. Okay, so with remote storage, we have a stateless compute layer, which basically means that it's going to run the database engine and it's going to contain only transient data. It's going to be operated by the Azure Service Fabric, and that's going to control the health of the node, and it's going to perform failovers to another node if necessary. We also have a stateful data layer, and that's going to store the database files in Azure Blob Storage. So if we take a look at this graph, we have 4 different nodes. They're going to be separated with compute and storage layers. So if the database engine fails, or it's going to be upgraded, it's going to be offline, Azure Service Fabric is going to automatically move the stateless database engine over to a stateless compute node. And data in Azure Blob Storage isn't going to be affected by this move. And the data / the log files are attached to newly initialized database engine process. Okay, so this is what remote storage is going to look like. And now let's look at what local storage is going to look like. So with local storage, if you're going to be using business critical and premium service tiers, this is what the backend is looking like. So you're going to have 4 replicas. Each replica uses that local storage model. Compute and storage is now going to be stored locally on a single node, except for the backup files. So if we take a look at here, we have 1 primary and 3 secondary connected through always on an availability group. The primary replica is going to continuously send changes out. And then once they are all up to date, in an event of a crash, if the primary or readable secondary goes down, a fully synchronized replica is always available for failover. So we also have this great feature with local storage. This feature is called read scale out. So read scale out, it's going to offer offload read-only operations such as analytical workloads to secondary replicas. And that's going to provide additional compute capacity at no extra cost, which is great. And the last one that we'll go ahead and digest is hyperscale. So one thing to mention here is that this is only for Azure SQL Database and is not going to be offered in Azure SQL Managed Instance. Now this environment is going to be called a distributed functions architecture. It's going to separate the query processing engine from the components that provide long-term storage and durability for the data. Now within these, we have 4 components that we're going to highlight here. The first one is compute. So each hyperscale database has a primary compute node for read-write operations, and up to 4 high availability secondary nodes. We also have page servers. The page servers act as a scaled out storage. It's going to serve pages to compute nodes on demand and update them. We also have log services. So the log service receives transaction log records from the primary compute replica and propagates changes to page servers and secondary compute replicas. And the last is the storage. So all database files are going to be stored in Azure Storage, which is kept up to date by the page servers. Storage is going to also be used for backups, utilizing fast storage snapshots for quick restores, sorry. Okay, so let's see what those compute tiers are. So with compute tiers, we have 2 options. We have a provisioned compute tier, which is going to be a fixed amount of resources. So if you provision 4 vCores, you're going to be paying for the 4 vCores no matter the usage. If you need to scale up, you can. And the other option is serverless compute tier. Now, with serverless compute tier, it is a scalable, cost-effective way to scale up and down. So a cool thing with serverless is that you're only going to be paying for what you use. So if you have some downtime in the middle of the night, your environment's going to pause and you're not going to be paying for that downtime at all. The one thing to note here is, I know some people would want to think, since serverless, you're only going to be paying for what you use. Why doesn't everyone use serverless instead of provisioned? Well, serverless, you're going to be paid or billed by the second, and provisioned, you're going to be billed by the hour. So serverless computer is actually going to cost you a little bit more down the road. So it is cost effective, but if you're going to be up all the time and you're only going to have a little bit of downtime, then that provisioned compute tier might be the better option for you. Okay, so let's go and think about when we go ahead and start transitioning into Azure. One of my favorite things that I mentioned was scalability. So with Azure SQL Database, we have that single database. We could go from 1 to 128 vCores or 32 gigabytes to 4 terabytes. Now, with hyperscale, this is the game changer. We could go all the way up to 100 terabytes, which is huge. So when you're going to transition to the cloud and you need a lot of data, a lot of memory, a lot of storage, Azure SQL Database does allow you to go all the way up to 100 terabytes. We also have a thing called Elastic Pools. So as I mentioned, Elastic Pools is going to be designed to solve unpredictable usage patterns. It's going to be for those that want some resource sharing rather than paying for a single database. Okay, so on the back end, we also have some hardware choices within all these. We have 3 options. The first one is the Gen 5. So the Gen 5, this is the most current up-to-date one. I think Gen 6 is going to be coming out pretty soon, but you have an 80 vCore limit here and up to 4 terabytes of local storage. We also have the FSV2 series. This is more for that compute optimized hardware configuration. And we have the DC series, which is designed for workloads that process sensitive data. Okay, so with all this, the biggest question is, what does business continuity look like? So we have 2 options when it comes to that. We have high availability and disaster recovery. So if you need your business to stay on, we have high availability, which a term for with high availability is a service level agreement. So as I mentioned before, we have the 4 nines. We also have 4 nines and a 5 with hyperscale. It's going to use a thing called zone redundancy, which we'll discuss in a bit. And with disaster recovery, we have a thing called RPO and RTO, which stands for recovery point objective and recovery time objective. Basically, how fast can we get you back up and running again? With disaster recovery, we're going to be using redundancy across regions, whereas with high availability, we'll be using that zone redundancy, and it's going to be within an Azure region. Okay. So with high availability, we have some zone redundant databases, and let's see what this is going to look like with this graph. So as we can see here, this blue square is going to be one Azure region. Within these Azure regions, we have 3 availability zones, and each one of these towers is going to mimic a data center. So with high availability, if your availability zone 1 is your primary, and that goes down for a man-made disaster, maybe a power outage, then you're going to be automatically spin back up in availability zone 2 or 3. So that's going to provide that high availability. You're going to be available very quickly. So let's see what disaster recovery looks like. So we have some options here and what disaster recovery looks like. So we use automatic backups. It's going to perform full differential and transaction log backups. You can't really configure them too much. So I think it's 2 days. Every 2 days, you're going to have a differential. Every 4 to 7 minutes, a transaction log backup will be taken. And that's going to be really helpful for those point-in-time restores. So a point-in-time restore basically means exactly what that name suggests. You're going to be able to restore to any point in time. We also have active geo-replication. So the single and pooled databases, it's going to allow you to configure up to 4 readable secondary databases in either the same or globally distributed Azure data centers. And all SQL database deployment options, it's going to allow you to use failover groups and load balancing at a global scale. So failover groups enable the creation of globally distributed SaaS applications with minimal administration overhead. Okay, so let's see how we can connect to Azure SQL Database and that connectivity architecture. So one thing to note here is we have two options. We have a proxy and a redirect. So every Azure SQL Database client is going to first, you're going to be first connecting through over the internet, which is a public gateway on port 1433. So the gateway, as I mentioned, it's going to either proxy or redirect your traffic. So if you're going to be connecting within Azure, the default connection is going to be proxy, or sorry, is going to be redirect. So if you're going to be connecting from outside of Azure, that's going to be proxy. So in this model here, the TCP session is going to connect through that gateway, and then it's going to go to that node. But because it has to go through that gateway, you're going to see some higher latency. The other option we have is that redirect. So this is going to be when you're going to be connecting within Azure. So the default connection, the default connection is going to go first through that gateway. But once that initial TCP session is established with Azure SQL Database, the client is going to redirect, hence the name, to the correct database cluster. So once that connection is made through that gateway, it's going to be a lot quicker because now we're going straight to that node. So that redirect option is going to be that more preferred option here. It's going to be a little bit quicker. With proxy, as I mentioned, you will have some higher latency there. Okay, so with that, I'll go and take a little break and see if we have any questions about anything I talked about with Azure SQL Database.
I don't see any questions, Yuki.
Okay,
yeah,
perfect.
Please.
Thank you.
Yeah, audience, if you have any questions, please post it in the chat. I'm watching out.
Perfect.
So yeah, this is amazing. Yeah, I loved your session. So please go ahead. Yeah.
Thank you so much. Okay, so I know we just went a lot about Azure SQL Database. Sounds like a lot of information. Let's go ahead and see what Azure SQL Managed Instance looks like. And then at the end, we'll go ahead and compare and contrast the two. So why would we choose Azure SQL Managed Instance? After talking about Azure SQL Database, that sounded great. So with Azure SQL Managed Instance, as I mentioned, it's going to be great for those that want a simple lift and shift migration to the cloud. So it's going to be easy to lift and shift. It's fully managed PaaS operation. It's full isolation and security, which we'll be talking about. We'll be using what is called a VNet. Okay, so with deployment, let's see what the options are for purchasing. So with the purchasing model, unlike Azure SQL Database, with the managed instance, we only have one option. We have the virtual core or the vCore based purchasing model. And with that, we have three options of purchasing. We have the standard series, which is Gen 5. We have the premium series, and we have the premium series memory optimized. So with standard, you're going to have 5.1 gigabytes of RAM, with premium, that's going to be increasing to 7, and with premium series memory optimized, that's going to be 13.6 gigabytes of RAM per CPU vCore. Okay, so with CPUs and vCores, this is going to kind of basically break down those three options that we have. So in the background with the CPU, as you go from standard all the way to memory optimized premium, that's going to be a little bit different. The number of vCores is also going to be changing. As you can imagine, it will be increasing, but not too much, right? So with standard, we have a limit of 80. With premium series and memory optimized premium series, the max is still going to be 128 vCores. The max memory is going to be increasing, as you can imagine. But the one thing to note here is this bottom tab is the max instance reserved storage. So if you're going to be transitioning to the cloud, this is one thing that you might want to note. You can only have a maximum of 16 terabytes. So if you need a little bit more, you're either gonna have to spin up another Azure SQL managed instance, or you might want to pivot and shift gears and go towards Azure SQL Database. Okay, so with the purchasing, let's see about service tiers. So pretty similar. We have three options. We have the general purpose service tier, which is going to be that default service tier when you spin up an Azure SQL managed instance. It's going to be for those that have some basic workloads and generic workloads. We have business critical. So this service tier is going to be those that need low I/O latency requirements. It's going to provide that higher availability, higher resilience, and faster recovery from failovers or failures. And we have the next gen general purpose, which is still in preview, which is basically the better version of that basic general purpose that we have right now. And some key reasons as to why someone would want that next gen general purpose, it's going to have better performance compared to that regular general purpose. It's going to have that same baseline cost, but it's going to have improved latency, throughput, and IOPS. Okay, so with general purpose, that first one, let's look at that architecture and see what that looks like. So it's going to be that same setup as Azure SQL Database. It's going to separate that compute and storage. We're going to have those two stateless compute layer and the stateful data layer. So in that case, it's going to be the same where that's stateless compute layer. It's going to use that Azure Service Fabric. It's going to control the health of the node, perform that failover. And stateful data layer, it's going to use those database files. It's going to be stored in Azure Blob Storage. And with this figure here, it shows 4 nodes. It's going to be separated with compute and storage layers. Okay, so this is general purpose, and this is what business critical looks like. So the business critical model, the compute and storage is integrated on each node. It's going to be locally stored. So very similar to Azure SQL Database, the replication of data between database engine processes on each node of a 4-node cluster archive. Or sorry, it's going to achieve high availability this way. As we can see here, each node is going to be attached. It's going to be using that locally attached SSD as data storage. Okay, so when connecting to Azure SQL Managed Instance, this is where the difference is going to really show in comparison to Azure SQL Database. So with Azure SQL Managed Instance, the instances are going to be deployed within an Azure virtual network and subnet dedicated to a managed instance. So you're not going to be going over that public IP address anymore. The setup is going to provide a secure VNet local IP address, and it's going to allow connections to on-premise networks or other Azure resources. So the managed instance actually operates on 2 planes. The first is the data plane, which is deployed inside the customer's subnet for compatibility and network isolation. The other plane that we have is the control plane. So this is going to manage the deployment, the maintenance, and core services in secure Microsoft managed environments. So both planes are going to rely on Azure services like the storage and the authentication, with all control communications encrypted and verified. So it's going to be a little bit safer if you really do need some more security, then Azure SQL Managed Instance might be that better option for you. So when connecting to Azure SQL Managed Instance, we have 3 options here. We could use that VNet local endpoint, which I mentioned earlier. So this is going to be that default connection method. It's going to be resolving to an IP address from the subnet's pool. We have that public endpoint. So public endpoint, it's an optional endpoint with a public IP accessible over the internet. So it's going to be allowing traffic on port 3342. And we also have a private endpoint. So the private endpoint, it's an optional fixed IP address from another virtual network. And that's going to allow traffic on port 1433. And like the public endpoint, it uses a proxy connection type. Okay, so when you're going to be moving towards Azure, one of those things that you want to consider is scaling. We talked about some scaling options that we have with Azure SQL Database. We could go all the way to 100 terabytes. But let's see what the difference is when we go with Azure SQL Managed Instance. So with scaling, we have a max database size of 16 terabytes, and we only have 100 databases max that we can be utilizing. With next-gen purpose, which is still in preview, you could have up to 500 databases per instance, which will be a little bit better than that 100. Okay, so scaling. Here we only have 16 terabytes. As we mentioned with Azure SQL Database, we have that 100 terabytes as an option. So this is one thing to really consider when you want to be transitioning into the cloud. Okay, so disaster recovery, it's going to be fairly similar to Azure SQL databases. We have a point-in-time restore and long-term backup retention. So point-in-time restore, as we discussed earlier, you're going to be able to recover from any point in time. With long-term backup retention, you can store full backups for up to 10 years. You can do less, but the max is 10 years. It's going to take copy-only backups with MI, but not with Azure SQL Database. Okay, so with compatibility, as we mentioned, Azure SQL Managed is going to be great for that lift and shift option. With Azure SQL Managed Instance, it has a near 100% compatibility with a regular SQL Enterprise server. So that's going to allow you, or it's going to actually give you less of a headache when going towards Azure. You don't have to do too many code changes. So if you're lazy like me, that managed instance might be that better option in terms of compatibility. So some key features that Azure SQL Managed Instance has that Azure SQL Database does not provide are cross-database queries, database mail, and agent jobs. So if you do require all these three things, Managed Instance does seem like the better option. We can do something similar with Azure SQL Database, but as I mentioned, it's going to require for a little bit more of a code change. So it's going to cause maybe some problems, and you're going to have to do a little bit more work with Azure SQL Database. With Azure SQL Managed Instance, you're already going to have these features. Okay, so we've talked about Azure SQL Database. We have also talked about Azure SQL Managed Instance. Let's see what the similarities are now. So at its core, it is SQL Server. So most of what you can do on a traditional SQL Server, you could do in an Azure SQL Managed Instance or an Azure SQL Database. The database management is going to be pretty much the same on both of these. The language features. Language features are going to be fairly similar. The control the flow language keywords such as data types, DML statements, and stored procedures are all going to be fairly similar. The database features such as auto-tuning, data compression, and partitioning is going to be the same. And the security features such as application roles, dynamic data masking, and row-level security. We also have multi-mode capabilities, such as graph processing, JSON data, and XML indexes. So these are some of the similarities, but now let's see what the differences are. So some of the key differences, these are the ones that I really wanted to highlight here. So when you're transitioning to the cloud, I think that these three are probably going to be the biggest bullet points that you want to consider. The scalability, the storage, and some of the features that both provide. So with scalability, Azure SQL Database is going to win. You have up to 5,000 databases here, whereas Azure SQL Managed Instance, you only have 100 databases allowed. So you can have up to 5,000 databases, but then you're also just going to have to spin up 50 more Azure SQL Managed Instances in order to hit that. With storage also, so that's where Azure SQL Database, you're going to have that database size of 100 terabytes. But if you don't need that much and you only really need a little bit less than that, Azure SQL Managed Instance does provide that 16 terabytes of database size. So some of the key features, Azure SQL Database does have that serverless and hyperscale, which is going to allow for that huge uptime and um, storage size and scaling. We also have query performance insights. That's basically, it's going to provide intelligent query analysis with Azure SQL Managed Instance. We have those key features as we mentioned in the previous slide, such as that cross-database queries, SQL agent job, database mail, etc. If you're going to spin one up, though, in my own experience, Azure SQL Database is a little bit quicker. With Azure SQL Managed Instance, every time I've spun one up, it's taken maybe 4 to 6 hours. So that's also one thing to consider also. Okay, so I know the one question that everyone has been waiting for, which one should I use, Azure SQL Database or Azure SQL Managed Instance? And the answer is actually really simple. It depends. It really does depend on your goals and your needs. As we mentioned before, if you need some key features, then Azure SQL Managed Instance is going to be the obvious winner. It's going to have that near 100% capability or compatibility. If you really need to scale up and down, Azure SQL Database looks like it's the winner there. So it really does depend on if you need to scale up or if you just need those features. If you do need those features, but you also need to scale, you have two options. You could spin up multiple Azure SQL Managed instances, or you can use Azure SQL Database, but it's going to require a lot more of those code changes. So in essence, SQL Managed Instance is going to allow for a more secure network integrated environment, while SQL Database is optimized for simplified, large internet-based access. MI is going to, or Managed Instance, it's going to offer a more complex network architecture with deep integration, as we talked about with Azure Virtual Networks. And Azure SQL Database, the connectivity is going to be primarily over the internet using public endpoints secured by firewalls. So if that's also a concern, so it really does depend on your sensitive data, how fast you need it, how large you need it to be, how many instances that you need. So the answer is very simple. It really does depend, as I mentioned, as with your goals and your needs. So with all this, I will go ahead and open up to some questions.